Hello, welcome to our channel for probability and statistics. In this video, we will talk about correlation, slope coefficient, and coefficient of determination in linear regression. So first we will talk about correlation between x and y. So here x is independent variable and y is dependent variable. And also, in linear regression, we often assume that the independent variables x are physical or scientific variable, not at a random specification. But in reality, all the variables are random because in the linear regression, we often assume that in a given x, there are random variable y. But actually, x itself can also be denoted as a random variable because x range different values in the sample, right? Because we get a sample and we do not know exactly beforehand what the value of x is. So x and y actually they are both random. So which means x and y has correlation coefficients if they are correlated. And if we look at the regression model, so y is beta 0 plus beta 1 times x plus epsilon. So this epsilon is independent random variables with x. So epsilon itself has variation with a variance called sigma square. And if x is random, x also has variance sigma x squared. And because they both two are independent, so the variance of sigma y is the sum of sigma square plus beta 1 square times x variance. And the mean of y given mean of y is the mean of x times the coefficient plus the intercept. So here beta 1 is the slope coefficient. Because x and y both random, so they have a joint distribution. So this is the joint probability density. It's a very complicated, but actually is the multiplication of these two random variables, then plus a parameter called rho. So here rho square is a division of sigma x square divided by the sigma y square times beta 1 square. So if we look specifically this equation, so the value rho is 0 if beta 1 is 0. So the rho is correlation coefficient between x and y. And the relationship between the correlation coefficient and the slope coefficient is this equation. So when beta 1 is 0, which will result when essentially is no linear regression because the slope is 0. So y is not connected with x. And in this case, their correlation coefficient is also 0, right? And because sigma square y, here sigma square y is larger than the sigma square. So we must have rho square less than 1 because this division is less than 1. So 1 minus this 1, which means this part is less than 1. So the rho square is less than 1. And rho also between minus 1 and 1. So the correlation coefficient between two variables is scale-free. It should lie between minus 1 and 1. But the slope coefficient is not necessarily between minus 1 and 1. It is not scale-free. So the beta 1 can be any value, right? So this is different, and their relationship is with the multiplication of sigma x square divided by sigma y square. So this is the relationship between the correlation coefficient and the slope coefficient in the linear regression. And if we denote R as the correlation coefficient, we just change the alphabet. R is same as correlation coefficient. There will be another equation. Its value is the division between Sxy divided by the square root of Sxx and Syy. What is this three parts? So Syy is the sum of square of y variable against its mean. So it is the sum of the square value. Inside the square value is each y minus the y mean value. So average of y, all the sample. Then take a square for all the observations. So this is Syy. And same for the Sxx is the sum of all observations x variable against its mean. Then take a square, then sum together for all the x variables. And Sxy is sum of all multiplication between x against its mean times y against its mean. So x minus x mean times y minus y mean. Then take sum for all observations. So this division equals correlation coefficient. So this is our correlation coefficient, the same as previous page. We just change the alphabet. And if we take a square root, this one is also has in the linear regression aspect, it's a division of SSR divided by SYY. If we take a square of this R, then the value is SSR divided by SYY. What is SRR? SRR is the module of y, odd y variation explained by the linear regression model. If we look at this is the linear regression line, and this is the y mean value, and this part is SST, the total y variation is also called SST. Then this is the SSR. This is SSR. And another part is SSE. So SSR is the variation of YY, is the variation of the module explain the total variance of YY. So this R square we can also call coefficient of determination, represents the proportion of the variation of SYY explained by the regression of y on x names SSR. So R square in every linear regression module result will have this value. It is between 0 and 1. So say R square is 0.95. So which means the variation of y variable Syy can be explained by the module 95%. In a simple linear regression model, which means it's only one independent variable, x, then the coefficient of determination R square, then take a square root, will equal to the correlation coefficient between x and y. So this only applies in simple linear regression. These two values is just the square relationship. So in conclusion, in the linear regression, correlation coefficient between x and y is actually the square root of coefficient of determination. And correlation coefficient between x and y is also equal to the coefficient equal to the square root of the coefficient, slope coefficient beta 1 times sigma x square divided by sigma y square, then take a square root, is also equal to the correlation coefficient. So this is the relationship between the correlation coefficient with the other two items in linear regression. Thanks for watching.